Welcome to the Rich Report, a podcast with news and information on high-performance computing. Today, my guests are from IBM. We have Chris Porter, he's the Worldwide HPC Cloud Product Manager, and Jeff Kamiol, he's the SDI Cloud Portfolio Marketing Manager. Gentlemen, welcome to the show today.
Hey, thanks a lot, Rich.
Thank you.
Well, thanks for coming on. You know, I've heard that IBM had a new cloud offering for HPC coming out of the old platform team, and I was hoping you guys could tell me more about it.
Absolutely, Rich. We'd love to. So to jump into our slides here on slide 2, IBM and platform's heritage comes from high performance and technical computing, but we've really started to generalize our offering in the cloud now that we've been able to get there. We've been focused on for 23 years now, compute and data intensive workloads used for simulation, modeling, and analysis, which primarily ends up being in places like aerospace and defense, automotive, chemical and petrochemical, things like parallel applications developed with MPI. But we're also focused, and as a heritage, have always been focused on a high throughput computing environments, things like electronic design and life sciences. Especially embarrassingly, parallel workloads, which really can exercise a scheduler in a way that really can test its ability to scale to thousands and tens of thousands of job slots and cores. And then finally, we've also been, as a company, focused on parallel service-oriented HPC environments used for Monte Carlo simulations and analytics. Primarily used in the banking, insurance, and financial services markets. But with that breadth of focus for us as a software company, we've been really able to cover a large percentage of homegrown commercial and government/open source applications out there. So next slide. The reason that we've gone to cloud, and we've really been sort of led there by our customers, is that we see some very common things that are happening across industries. For instance, we're seeing certainly an unceasing demand for compute, and that's just a steady state march of needing additional compute power and storage, if you consider compute or storage part of compute, which certainly we do, and that feeds into the whole data growth idea that we recognize now that as folks are doing analysis, whether they're doing e-commerce, they're doing simulation, they're doing even just collecting all kinds of data on their customers, clients, or even interactions with folks and their habits, all that data gets saved, and that is also driving this unceasing demand for compute and data growth. And both of those things are very, very challenging for clients that have traditionally even long-standing clients that have traditionally had their own data centers, because this growth is most definitely exponential, and it may be even faster than exponential in some cases. And being able to plan for a data center with that kind of growth rate, especially at the sizes that we're already at, means that generally the plans that you put in place once they've been approved, et cetera, and go through various things that are required by a large corporate organization, they're already too small, too late. So really the world is demanding this very, very fleet of foot agile type of environment, and that's really where the cloud recipe comes in. That's the first thing that people think of, and justifiably so. We see that folks that are not paying attention and or simply haven't been able to adopt these technologies yet are unable to meet their business objectives, meaning I can't make or release the chip that I want to do on the time frame to make the Christmas rush for the cell phone, or I can't get the car that I want to release for next year. I can't do all the analysis that I need to make it quieter or more gas efficient or more powerful, or make the hybrid algorithm that I'm using to make my car advantageous over the various competitors in that market really work the way I'd like it to do, and that's not acceptable, of course. We see that these environments are getting more and more technical, even though the applications are remaining the same. Very often, the applications are being tied together. So you have multidisciplinary types of analysis, and the requirements for those kinds of analyses are simply shifting the expertise requirements toward very, very difficult to find, highly skilled people that are not that many in the world. And so it's a difficult thing for in enterprises to grow simply because the talent that they need to grow is either time-consuming to develop themselves or difficult to find out there in the world. So, next slide. So when a client comes to us with these kinds of problems, very often they have this myriad of, I'm having this problem, I'm having this problem, I'm having this problem, and even when we start talking through solutions, because generally they're very, very smart people, there are all kinds of roadblocks that they see, and a number of these things are roadblocks that can stop a cloud from functioning, and I'll just pull out a few of them. But certainly security is one that everybody is very, very worried about today. Just look at the news, look at CNN right now, and you'll see at least the evidence of two different enterprises being hacked for user data, and I'm sure that trend will continue. So we understand that especially for our traditional clients doing HPC, we're asking them to put their intellectual property in the cloud, meaning make it leave their premises, and that's a scary thing. And so, by virtue of that, we expect that we need to be even more secure than they are on site, and that means every bit that gets transferred to our cloud gets encrypted. It means that every bit that is at rest in our cloud is encrypted. And then we can get into the specifics of the encryption if anyone cares, and we certainly do that when we are engaging with a client to make sure that the levels of security that we're offering are what are needed. And if they need more, we can do more. So, and that actually brings a good point. Another thing that people often in HPC are concerned about when it comes to adopting a cloud type of model is data movement. Typically HPC and technical, scientific, and simulation analytical and data heavy workloads require a lot of data movement. You have to get the data to where the processors are before you can actually take advantage of the cloud model. That's certainly the case. And that's something that we have focused on for quite some time. In fact, IBM and Platform have integrated a set of technologies which are not only software-based but also hardware-based to maximize the throughput and minimize the time that a client would need to wait between when he needs data in the cloud and when it actually arrives and is available for processing. So we could talk a bit about each of these. We probably run out of time, so I'll save any more discussion there for question and answers. So next slide 5. So this is at the highest level, sort of our stack view of what our cloud service really is, and it's different in a lot of different ways. So starting from the bottom, we leverage the SoftLayer infrastructure. So SoftLayer is part of IBM now, and SoftLayer has a number of unique characteristics, which are really the impetus for us to launch our cloud service. The main parts of SoftLayer which were compelling to us was that SoftLayer, unlike most of the other clouds out there, is uniquely positioned to be able to do high-performance computing type of processing. And when I say that, we're talking about infrastructure that is not virtualized. We're talking about bare metal infrastructure of the latest and greatest processors that you get your hands on. Right now, our standard processor is a Haswell. We offer high-performance networks, not only 10 gigabit Ethernet, but also FDR InfinfiBand. We offer accelerators in the form of GPUs from NVIDIA. We offer parallel file systems, and not just the standard open source parallel file systems that you might be able to do yourself. But we're talking about Spectrum Scale, the quintessential parallel file system from IBM. Which is here in the next box up from the SoftLayer infrastructure, IBM High Performance Services for data. That's leveraging Spectrum Scale technology. And then on top of those two building blocks, we can start talking about what the use case is. And depending on what the use case is, whether it's a high performance simulation or whether it's an analytics type of application where you're talking about small jobs or short running jobs where you have millions of them to process, you're talking about a Hadoop or Spark workload, or even very specifically an electronic design workload, which we can talk about in a moment. We have very specific offerings and tools around each of those to make to provide value to our client, to maximize their throughput, minimize their costs, and really give them maximum bang for their buck. And then I think probably the most unique thing about our offering is that all the HPC experts that I referred to earlier, the people that are very, very hard to find, they're the people that we have been collecting for about 23 years now, in the form of employees of IBM Platform Computing. But now we've collected them into a single group that we call our Cloud Operations Team. And it's a worldwide team with 24/7 support, and they're the people who do our support, but they're also the people who do the builds. Now, when I say the people who do the builds, what this means is our offering, unlike other offerings, is very often you start with a blank whiteboard and say, what is it that you're trying to do? And then we tailor the environment to exactly what a client is trying to do. It's very different than going to one of our competitors where they say, well, these are the dozen offerings that we have. You have to choose one of these, and if you have a requirement that falls outside of these, then sorry, you can't use our cloud. That's not how we operate. We operate very differently, and where we start off with that blank slate, and pretty much what's available out there in terms of cutting edge that would be interesting for HPC is what we have access to. And our cloud operations team have the directive to be the glue, to do the build, and then be the people that answer the phone if and when a client has a problem. And so that means that the people that are answering the phone on the other end are intimately familiar with what exactly our clients are using because they're the people who built it. And then finally, after that, then our clients will be invited into their environment to upload their applications, provide us their user authentication method, and we help them get connected. That's really how our engagements work. So next slide and last slide. So we really see that our offering is unique in a number of different ways, but I'd like to hit those one by one. The first one is, and I just talked about it through our cloud operations team, is our expertise. We come from scientific, technical, analytic, and data processing types of computing. That's our background, and we've been doing that for decades. We have built software schedulers that are recognized in the market as the best schedulers out there. They also may be the most expensive. I'm not going to argue that, but they are most definitely the best out there. We offer flexibility in the form of middleware on demand, in that we don't require any longer that a user or a client buy permanent licenses for any of the workload management tools or even the infrastructure that they run them on any longer. So a client can come in, do processing for the period of time where they have workload, and then shut things off and stop paying for it. And really, with today's very, very dynamic market where it's very uncertain what's going to happen in the world, whether it's a possible some sort of vehicle tragedy, or it's a financial collapse in Greece, for instance, or some other unforeseen event, which sparks a lot of analysis to be prepared and measure the risk or understand what has happened. Those kinds of things are simply unpredictable, and therefore the workloads associated with them is unpredictable. And that's really one of the wonderful things about the flexibility of cloud. Additionally, once you recognize that cloud and the flexibility is what you'd like to leverage, the next question, and it's often on the minds, at the forefront of the minds of folks that are focused on HPC, is the H, performance. If I try to run my HPC workload and I have a grid or access to a cloud, but that cloud can't perform at even close to my local resources, then I really haven't bought myself anything. The business case doesn't help me because I can't get the workload done. I can't get the answers that I need answering in the time frame that I need them, and so cloud wouldn't help. And that's why we think that the SoftLayer infrastructure, combined with our workload management tools and the expertise that we bring to the table, is the recipe for making our clients successful. reliability. Well, we have market-proven workload management tools that have been around, as I said, for decades. So, and for the industries that we're a part of, these tools are recognized as rock solid. Our security, as I said, is continuing to develop, but already every bit that gets moved to the cloud and from the cloud is encrypted, and every bit that sits in the cloud is encrypted to make sure that intellectual property stays safe. And then finally, adding all of these things up together, what we're really providing is value to our end customers with regard to those short duration workloads. We can make sure that the efficiency that our clients get for their high value applications, because often those application licenses are extremely expensive, we can make sure that the value that they get out of those licenses is maximized, so that not only do you get the throughput for the workload that you need, but the expenditure that you have on resources, not just people, but also the software licenses, is maximized. With that, I would say thanks very much for listening to my little spiel in the slides, and let's open it up for questions. If I didn't touch on anything, or you're curious about anything.
Oh, definitely. Thank you for that. I'm curious. You've given a great summary here, but what sets IBM High Performance Services apart from the other vendors offering HPC cloud out there?
Sure. So I guess it depends a little bit on what you compare us to.
Yeah.
So as I said, our cloud operations team, I think, is unique in the market. Is 100% unique in the market. So it doesn't matter what you compare us to. Having HPC experts like that is just fundamentally unique, and have them be the ones that not only do the builds but do our support for us in a worldwide fashion, not just in a single location.
Right.
But there are other things, depending on who you're comparing us to, that also might be fundamental differences. For instance, if you look at Microsoft Azure, or if you look at Amazon EC2 or other clouds, you might say, well, I don't want to use virtual machines because I know that a virtual machine will impact my ability to do high-performance I/O or do low-latency communications, which are very important for large-scale parallel applications. That's certainly the case, and that sets us apart in that we offer bare metal. In the case of other smaller cloud providers that may offer low latency communication, they're simply not globally situated. We have 40 data centers scattered around the world in all three major geographies of Asia, North America, and Europe, and soon to be also in Australia, New Zealand, and South America. In fact, I think we just opened one in South America. That this solution will be available for. So we recognize that these global organizations are themselves global and have analysis needs around the globe, not just in North America or not just in one location. And so that sets us apart as well.
Well, great. You've got that locality, but what about expectations? I mean, could HPC users really expect their apps to run, the same kind of performance in an HPC cloud as they have as in their in-house facility?
Absolutely, they can, and
yeah?
that is a concern. So I used to joke with people that sometimes people think cloud takes the H out of HPC. And the only thing that really can close that discussion is benchmarking. And we've done a number of benchmarks. We have a set of benchmarks which we're happy to share with the world. We published papers on it. Right now, I believe we have our cloud benchmarks published on the website for MSC Software, which shows the performance that we can achieve on our cloud compared to the best on-premise hardware from our competitive vendors. So we're comparing our cloud to if you bought something right now from pick any OEM that you like, and our performance is on par, if not better, than their performance as it is. And we're not even talking about their cloud. We're talking about their on-prem hardware. So we're very, very happy to entertain benchmarks with clients, and we certainly have various vertical markets that we specialize in, where we know the answer is yes, absolutely. We've already done the benchmarks, But each time we often we'll get surprised also, and where we get requests to do benchmarks or pilots with clients to check the performance to make sure, yep, it really is as good as we say it is. And so far, knock on wood, we have been superior each time we've done one of those engagements.
Well, great. Given that you have that performance parity, when does it make sense to do HPC in the cloud, and when does it make sense to do it in-house?
Yeah, that's a good question, and the answer is of course the consulting answer. It depends.
Yeah.
And mostly what it depends on. I think the biggest factor is the client's data center.
Yeah.
If the client has a data center which has available capacity, then usually the right answer is once a workload falls between, if you look at a year, falls between about a third of the year and 50% of the year. If you have, so call it maybe more than a third of the year I would spend processing this particular workload that I'm considering for the cloud, then it's probably economically advantageous to simply buy hardware and process it in-house. Now, that being said, that makes a lot of assumptions about, well, then you're going to have to go through a procurement cycle, and the workload can wait for that, and all kinds of things associated with acquiring local hardware. But if you have a workload that is less than that, less than a third of that year, then it definitely does not make sense to purchase permanent hardware, because for 2/3 of the time it's going to sit idle, and so you're going to actually be throwing money away. And it actually makes economic sense to use the cloud, even though per hour or per month the cloud may be more expensive than your amortized costs.
Mm-hmm.
If you're not going to use something for the full 3 years that you can amortize it over, then it's just wasted money.
Right.
And so that's really the sweet spot. Now, if there are folks that have data centers that are at capacity, and you're considering having to build or rent an additional space in the data center, that changes the equation entirely. And then you're looking at more like 66%, 70% of the time, or less when cloud is advantageous.
Well then, okay, given that, how do you solve the data transfer problem, like getting data into the cloud and out, because you're limited by that network bandwidth?
Yeah, the pipe. So we have a number of technologies that are associated with managing that. So the first one is a product from Platform's workload management tools called Platform Data Manager, which allows a client to define the data that is required for a workload to run in another location, where that other location could be the cloud. And then let the system itself decide when to transfer data, when not to transfer data, and when to tell the workload managers either run that job locally or run it remotely. And so it can make an intelligent decision about what data to transfer and what not to. So send the jobs with small amounts of data to the cloud, for instance. That's a very simple statement of what one of the things the algorithm can do, but it absolutely can do that. But sometimes that's not enough. Sometimes you only have large jobs that need to be transferred. Or large amounts of data that need to be transferred to be able to do the processing in the cloud. And in those cases, we have some very specific technology from Aspera, which is another IBM acquisition, just like Platform and SoftLayer, that will assure that a network pipe, is used at maximum efficiency. And depending on the distance that the transfers are happening over, if it's happening over the ocean, then we've seen very, very large movement accelerations. But even within North America, which surprised me very much, I believe we did a test transferring data between Seattle and Dallas, and we saw up to a factor of 3 performance improvement in data transfer rates, even though we were using a low latency, high quality network with very little dropout. So we have a number of technologies that we can bring to bear to minimize the pain of that data movement. But in the end, we still can't defeat the speed of light, and sometimes you can't beat the bandwidth of a FedEx truck carrying hard drives.
Sure.
And that's a service we offer also that costs no money. If somebody wanted to transfer terabytes or even petabytes to us, we offer that as a free service for no additional charges. They just simply need to pay for the storage in the cloud to transfer that data to. And they can move that data to us easily.
Very good. So that's the technology side. What about the people side? You touched on expertise. Does IBM High Performance Services include things like professional services outside of HPC?
Absolutely. We have well, as I said, we have a cloud operations team, and that cloud operations team is primarily focused on HPC. And when I say HPC, I'm kind of blurring the edges of that a little bit because they're very happy to work on Hadoop and/or Spark engagements, which we have very specific experts in analytics and service-oriented architecture type of workloads, which sometimes are called HPC, sometimes they're not. But even outside of that, if you're talking about enterprise-style computing and/or maybe something that it doesn't have anything to do with the cloud, or it does have to do with the cloud that has nothing to do with platform's traditional businesses, we have a pure professional services team that's happy to engage with the client on those things as well.
Yeah. Well, kind of a wrap-up question here, guys. I wonder if you could describe the kinds of clients that you've engaged with this. Are these big companies that already do HPC, or do you have to convince them that cloud is a good idea, or what's it look like?
So the primary types of customers that we've been engaging with are platform's traditional customers that do large simulations and analytics.
Yeah.
Not surprisingly, we had a set of customers. We took the software that they're using on premise and we took that to the cloud in a new model. So it was an obvious place to start from a sales point of view. So they're the primary customers. They're the ones that are doing large automotive simulations, looking for oil, trying to discover the next drug, the next therapy, etc. Those are the types of customers that we've started with. But we've also quickly noticed that there is a set of customers that are outside our typical reach, who were always isolated from from being clients from us because of, as I implied earlier, because our price tends to be perceived as extremely high. But now that we can offer a pay-per-use license for super high-quality software like our workload managers, and allow someone to use that just for the period of time that they need it, then the equation really changes. Well, if I have to permanently license something and I only need it for a week or a month, that's kind of a difficult thing to justify. But if I can pay for it for just that month, then that's very easy for me to justify. And so the smaller clients that we as a heritage didn't engage with, we have started to engage with.
Well, great. I guess kind of a wrap-up question. How hard is it to kick the tires on this and see if it's right for my organization?
Very, very easy. So I would encourage anybody to use the URL that we've provided and the contact information. We have demonstration systems that we can provide to customers that want to try something, and it has all of the technologies that I referred to: InfinfiBand and Spectrum Scale and GPUs and actually graphics processors, which I didn't even talk about. Not just GPUs for doing processing, but I mean graphics processors for doing graphics. And all the other technologies that are very, very interesting about our cloud, along with our workload management systems and analytics systems, so that someone could really give it a try to maybe run a benchmark depending on what their requirements are. Certainly give it a try and say, wow, okay, that's certainly something that's worth considering.
Well, this is exciting to me, the idea that I can get on a actual bare metal supercomputer over the cloud and try something out through an experts like at IBM. So I want to thank you both for coming on the show today and telling us more about IBM High Performance Services.
Thanks, Rich. It's been just a pleasure.
You betcha. Okay, guys, that's it for the Rich Report. Stay tuned for more news and information on high performance computing.